Hi, I'm Kim Hamilton Duffy, CTO of Learning Machine and co-chair of the Credentials Community Group, which is the W3C group that's behind a lot of the standards or ecosystems prototyping. Okay, so how I got involved in self-sovereign identity, I've not been involved as long as many of you here. So how it started was through Learning Machine. We worked on a project called Block Certs. It was an initiative that we led with the MIT Media Lab. And the goal with it is, okay, so with open badges, which you may or not be familiar with, the problem with it was always the verification part. It relied really heavily on issuer hosting, or basically the issuer had to basically host a live site every time. If not, you don't really have your credential anymore. So the idea that we were working on with MIT Media Lab was that through blockchain we can solve some of the decentralized trust problems. Now, we started out as an open badges extension, but then through that community, that's where we found out about verifiable credentials. And obviously the big problem that comes up, so we built an open source, open standards ecosystem around it, but the big problem when it comes to creating these recipient-owned long-lived credentials is, of course, identity. And open badges, the way that they solved it was email addresses and a lot of other things that don't really work well. So also through our finding the verifiable credentials group of people, we learned about DIDs. And so since then, we've been working to get the Block Cert standard aligned with this whole ecosystem, including verifiable credentials and DIDs. We've also been prototyping the BTCR method spec, which I'll demonstrate here. Okay, and so the W3C CCG, what do they do with self-sovereign identity standards? Most importantly, now we're working on the DID specification, and we are presenting it at W3C TPAC this year to hopefully get it taken on as an official working group. We also host sort of informal, things around DIDs, such as DID method registries. So, for example, all of the different DID providers can register their sort of namespace with us. But in general, it's a very lax standards group, if that can exist. We do a lot of prototyping the ecosystem and incubating things that will ultimately feed into standards. The other thing that we are working on are signature, now we refer to proof suites, in case you see those words used interchangeably in a lot of our samples. A lot of the terminology is being updated. And yes, this advanced thanks to SSI Meetup. I think you'll notice, and I try to minimize duplication, but a lot of us just remix each other's slides, so yes. Okay, so the agenda, first I'll do a quick review of the identity models. Some of this, if you saw Kalia's talk, will be familiar, so I'm going to move pretty quickly through that. Then we'll take a glance at DIDs to see the basics of it. Then we'll look at the self-sovereign identity standard stack and the role that DIDs play in it. Next, we'll talk about DID method specifications, sort of as context before getting into the BTCR method spec. What I want to focus on here is a light survey of the different DID method specs, why there's multiple of them, why you would use some versus others. Then we'll do a deep dive into BTCR, and then Q&A. Okay, so first, starting with identity models. This is the centralized identity model, and in this model, you are a supplicant, and it's not necessarily your data, or metadata for that matter. And this leads to data silos and basically targets for hacking. Federated identity is, we basically have someone in the middle of that who's dealing with the complexities of identity management, hopefully. So, the advantage is you can use it across systems, but it still suffers from many of the same data silo issues that the previous one did. And then, so we call it the pass the buck model. But at least on the bright side, there are some standards that were used to achieve that. So these, just for context, for federated. And lastly, with self-sovereign identity, this is really what we're all here building. With self-sovereign identity, the promise is that you can exercise ownership and control over all aspects of your identity. And you can control what you choose to reveal, so that in theory it should be more privacy preserving. As an implementer, I hedge a lot by saying in theory. Everyone else will say yes, so don't be discouraged by hedging. Okay, so now let's take a quick look at DIDs, which are the fundamental building block of the self-sovereign identity stack. This is not a DID, and we can refer to this as a dumb string. So, you can't really do a whole lot with it on your own. Other people can, if they happen to get a copy of yours and maybe some other personal information. They can do a lot with it. Now, DID, on the other hand, we'll call this a smart string. And so you can do things like prove you actually control that string. One other important part, and that's intentionally fuzzed out so you don't worry about it yet. There's a DID document which basically enables that proof that I demonstrated on the previous, or that I previewed on the previous slide. So a DID resolves to a DID document. And then that DID document contains all the rules for how you might authenticate and various other operations that we'll get into. Okay, so now let's talk about the self-sovereign identity stack, the standards related to it, and basically where DIDs fit in. So yes, let's just go through these and talk through sort of what each layer does. So the DID specification layer, that covers the common data model format and operations of DIDs. That includes DIDs and DID documents. At that layer is also where you get the interoperability between method specs, which are the next thing. So method spec is the rules for how a DID is registered, etc., on a specific ledger or network. And when we talk about a survey of different DID method specs, we'll see sort of why some people choose some approaches versus others. But essentially, they have to conform to the DID specification, but also there's a lot of innovation that happens in the DID method specs, which we'll also look at. Universal Resolver is Marcus's project that's very useful once you have a bunch of different method specs and you have a string presented to you. How do you uniformly look up the DID document corresponding to that? DID auth is how to authenticate with the DID. And lastly, verifiable credentials. That's the uppermost layer that I'll talk about, and that's really the credentials that you can possess, and they're associated with both the subject, the recipient of the claim, and the issuer. Okay, I think I'm using too much time. I'm going to move a little faster. Okay, so the DID syntax, I'm using this as a reference, sort of highlighting where in the stack we're talking about. So this is a DID syntax. We have the DID scheme. BTCR is the method that we're showing here. As I mentioned, the CCG group has a registry of possible schemes you can use, or methods you can use. And then lastly, this method-specific identifier is specific to how that DID method spec generates them. In a DID document, in a DID document, I mentioned this is basically what the DID resolves to. So in this is, the one I'm showing here is pretty much a vanilla DID document, nothing special, no method specific stuff except for this example service, which is kind of meaningless. So in a DID document, these are the standard parts of it. So you have the DID itself for describing itself. You have public keys, which are used in various ways. Basically, you can use it to verify control over the DID document. We also have a section authentication. So what's interesting is that the DID document itself has very limited capabilities sort of baked into it, and this is because we realized sort of at the last minute we didn't like what we were doing. So we knew we wanted to switch to an object capabilities model, but then we realized we just didn't know enough about the use cases to perform the right abstraction at this level. So instead what we're doing is allowing a lot of the DID methods to actually innovate, and then we'll pull those up in the spec. But this was sort of a disappointment to a lot of people. The things that went into the final DID spec, very limited, but I feel like it's a good trade-off. The service endpoints, this is where you can do a lot of interesting things. We'll get more into that. And that tends to be something that's very method specific. And it's basically the hook for methods to sort of do their own thing. We have a timestamp for audit history. So in theory, you could say, what was the state of this DID string at a certain point in time? And then lastly, the signature for integrity. Okay, now let's talk about how Universal Resolver fits in. So you have the DID document. Universal Resolver is the thing that's looking that up. So in Universal Resolver, it knows about various DID method specs, and so it uses those rules to perform that lookup. DID auth, and I apologize, I didn't know how technical the audience would be, so it's pretty anthropomorphized. So let's see, we're going to show basically in the self-sovereign identity model how DIDs are used. So here's my DID, formatting got bad. So the peer will resolve the DID document with this universal resolver. And through that, it can inspect to see, what are your authentication keys, and so it can challenge you to prove that you own it. So I create the proof, present it. Okay, so then my peer can look it up as well. So now we're going to throw in some verifiable credentials as well. So say your peer is a car rental agency, and I want to rent a car. So the peer will ask to see my driver's license, and I can dig up my verifiable credential that the whatever state or country issued, and then present it. And let's look at verifiable credentials. So this is the display layer. That could be encoded as a verifiable credential in something like this. Again, apologies for the formatting, which is slightly off. But this is effectively a verifiable credential, which is a very minimal structure. And its idea is to enable maximum portability. So depending on which use case you're talking about, like whether it's driver's license or educational credentials, things like that, you would use a different vocabulary for it. And then the thing I want to point out as well is that both the issuer and the recipient, shown right here, are identified by DIDs. Let's see. So we'll get more into this later. Okay, so the key point is that you can prove this is your credential. If this is my DID, someone can challenge me, and I can actually show that that I have ownership of it. And the other part is that, in theory, I can recover ownership of that credential even if I lose my device that stores all my public keys at the moment. So quick highlights before we get into DID method specs. So yeah, you can cryptographically prove ownership of your credentials. The layered approach of the self-sovereign identity stack does avoid some past problems, such as mixing authentication, authorization, other things that sort of systems have complicated in the past. And then lastly, which I think is the most important part, is that it factors in the key life cycle. The idea that you might lose your keys or something like that is not a special case. That's really built into DIDs, although implemented in very different ways. Okay, so we're going to look at some DID method specs. The DID method specs define their syntax. Basically all the operations you can do on it, how to create one, read, update, delete. And this applies to the DID strings and the DID documents. And also it specifies a ledger blockchain that it operates on. And also it can present any special method-specific elements. So, and there are representatives from Sovereign and Newport in the room, so feel free to call me out if I've gotten anything wrong in the survey. And actually I have questions for you afterwards. So, okay, so here's some examples. And, first question is, why are there so many? And it's basically that they're solving different use cases, and in some cases they'll enable different capabilities. Depending on the implementation, it can also lead to different economic models and trust models. So, so basically that results in different implementation choices, which we'll just do a quick step through. Okay, so examples of different use cases. One of them is ease of onboarding at-risk populations. So this is the sort of refugee scenario that many people in self-sovereign identity are trying to solve. So what they want to do is cheaply register, identify a whole bunch of people. So some examples of this is not an exhaustive list, by the way. So if your favorite method isn't here, it's not meant as a slight. Sovereign uses the concept of guardians to help enable that. Veris1 uses a board of governors to achieve that. We'll get a little bit more into how to do it. Another use case, PTR, which I'm working on, our whole goal was just to ease bootstrapping into DIDs. And it also served a really nice sort of educational point in that, it's just using the Bitcoin blockchain. And so it's really simple to start understanding DIDs and how to work with them. So that's really why I wanted to get involved in implementing it. And we have a bunch of tools that you can use as well if you want to start playing with it. The cool thing about it is it's self-sovereign. You can just go create it, assume you have Bitcoin. And if you've ever transacted Bitcoin, you have the PTR DID, and I can show you how to look it up. The last use case, not exhaustive, is it can be used to bridge existing systems. For example, Blockstack has a DID. And all of these, the spec isn't even released yet, so when I say DID, take that very lightly, but are working on DIDs. One thing, Uport is an example of these different use cases that they provide. So ERC 725 uses a smart contract, but as they were looking into it, they realized the need for a more cost-effective way to go about it. So, there's ERC 1056, which is the lightweight alternative. Let's see.
Excuse me.
Yeah.
From Newport, we don't support ERC 725. We never have.
You never have?
Never have, no.
Oh. Interesting.
So it's in the Ethereum space, there's another group of people supporting the 725.
Oh.
And they market this one, and we are saying it's not privacy preserving because they put everything on the blockchain.
Interesting.
Like that.
Because we...
Yes.
Yeah, that's fine.
We'll have another presentation in the afternoon from Newport, right? So we can look at it.
Thanks for catching that, actually, because I think that we still have that in our registries, so that's good to know. Okay, so the other thing is that depending on the priorities of the method, there can be different capabilities. So Sovereign's been really great about innovating in some sort of advanced signature schemes, zero-knowledge proofs, and also the other nice thing, so as I mentioned, that they have this guardian model, you can also transition it to, like, say, when you get to a point that you can control your identity, it can transition to an owner model. Verus One, where they're sort of innovating technically, is in OCAP, or object capabilities. So I'm really excited to see where they're going with it, because I think it'll heavily inform the next steps of the spec. And in general, each method spec can introduce their own vocabulary and behavior. And a lot of things that we talk about in terms of recovery, the things I mentioned that it factors in the key life cycle. A lot of that is aspirational at the moment. Some of the things that you'll hear referred to, like social recovery, maybe not really implemented yet, but these are things that people are focusing on. Okay, I think I'm definitely using too much time, so a quick survey of some different ledgers. Let me go right on. So some of the big trade-offs that follow from that previous one, though, some trade-offs you see, they're permissioned or permissionless blockchain, some are fit for purpose. You can also ask the question, who can run a validator node? So that leads to different, sort of results in who, your trust model. Whether outsiders can perform the CRUD operations and effectively the economic incentives, or who pays for it. So in general, a fit-for-purpose blockchain can sort of optimize for certain scenarios, but it's not necessarily cheaper to run the network. Different forms of on-chain, off-chain for DID document storage. Different update mechanisms. I'm just going to plow through. Okay, so quick focus on the BTCR method spec. So the BTCR DID format is this, so that after the first colon, we know it's the BTCR method. This last string that we see is a best32 encoded transaction position reference. So that encodes the network, so whether it's mainnet, testnet, block height, and the position within the block. So from that, you can go to unique transaction in the blockchain, and then from this point, you can look up details about the transaction, and from there you get additional information about the DID. So to create one, you basically just create a Bitcoin transaction with this optional out-of-date term, DID continuation document, which has additional keys or sort of authentication methods that you might provide. So when that is accepted and in the chain, you get a TXREF of that transaction. So TXREF, it's important that it's different from TXID, because TXID being the hash, but TXREF means it's actually been confirmed and it's on the blockchain. Let's see. Okay, so yeah, and that's basically how you get your DID. Now, updating it, you're just spending the previous output. So to find the latest, you just follow the chain of transactions on the latest unspent output. Okay, and now let me get into the demo, and then I'm closing now. Oh, cool. Okay, this is the BTCR TXREF conversion playground. And all of these are open source, and all the libraries are linked to. So we have some sample. Okay. Oops, now I messed it up. Okay, so it is looking up the DID document in phases. So the important thing to note here is that VTCR, it creates an implicit DID document from the transaction, which is one thing that's pretty powerful about it, because it didn't need anything else. Like basically, if you sign something with the same signing key you use for your Bitcoin transaction, you can prove that's your DID. So this part is what we get from the transaction itself. Okay, so I'll just talk about phase 2. Okay, if the transaction had an op return pointing to additional DID document material, then the resolver would look that up and then splice that in to the final constructed DID document, yielding the document in phase 3. So I'm going to close it there. But if you have any questions about the site and using it, let me know. You can create testnet ones as well.